Hey Geometries, this is Mr. Bloom and I am getting you ready for, watch me delete something. We're looking at lesson 7.2, similar polygons. This is day one. Okay, our objective today, students will be able to identify and apply similar polygons. Again, students will be able to identify and apply similar polygons. The theme is really corresponding sides ratios. Ratios of corresponding sides. You may have done these another way and they will work sometimes, but if you set up corresponding sides, it will work all the time. Okay, so keep that in mind. Let's move on here. We're looking at the idea of algebra review solving quadratic equations. Ooh, quadratic equations. Oh my. We can solve quadratics in two ways. Method one, factoring. Okay, so when we're looking at factoring quadratics, remember we have ax plus b times cx plus d. Remember when we'd multiply these together, we'd go a c x squared. Those are my firsts. Okay, then I do my outsides, and my outsides are plus a times dx plus my insides, and my insides is b times cx plus my last, and my last is b times d, bd. Now, when we factor it, we're trying to do it the other way because remember, these two would become the inside-outside terms, and that would be FOIL. So now, keeping in mind with this, when we have a leading term that's a integer that's prime, whose product is 1 in itself, I have only one choice, 7x and x. Now, when I have a final term who's a prime number, I only have what numbers make 1? Well, when they multiply together, they become 1 and 1. Now I've got to be able to multiply my outside and inside terms because that's really the big thing. I got to take my outside terms, my outside 7 times 1, and my inside terms 1 times x, and go, 7 and 1. How do they become 6? Well, if one of them was negative and the other one was positive, it would be a positive 6. So this would have to be a positive 1. That would have to be a negative 1 for us to make this work. Now, once I break it down using methods of factoring, I have to keep in mind I'm going to use something called the zero product rule. The zero product rule is directly related to the fact if I have two numbers multiplied together and their answer is 0, one of those numbers have to be 0. So I have two numbers here. I'm not sure if you noticed that this is a representation of one number, this is another, and they are multiplied together to become 0. So one of these have to be 0. So how do we do that? So either 7x minus 1 is equal to 0, or x plus 1 is equal to 0. Now, when I do this, I got to think, all right, I'm going to solve for x. So 7x is equal to 1 because I add 1 to both sides, and I divide by 7, so x is 1/7. Or I subtract 1 from this side, and x is equal to negative 1. These are the two values that'll make my value 0, and they happen to be the answer for this problem. So this becomes 0 when x is either 1/7 or negative 1. Those are my answers. Now, if I can't factor something easily, I use something called the quadratic formula. Now, the quadratic formula you've seen before, if I have my relationship here, ax squared plus bx plus c equals 0, I have it in this form, I can actually assign the leading coefficients to be a, b, and c. In this particular case, a is negative 3. B is negative 5, and C is 1. Now, this pattern gives me the idea of how to assign A, B, and C, but the actual formula is the values of X will be found by using the opposite of B plus or minus the square root of B squared minus 4AC, all over 2a. Now, since I've already identified a, b, and c earlier, I can now just plug those values in. So the opposite of -5 is 5, plus or minus -5 squared, which is 25, minus 4 times a, and we're going to do this, 4 times a, which is -3, times c, which is 1. Now, that's all over 2a, which is 2 times -3. Now I'm going to evaluate this carefully because the number one mistake we'll make as a student doing this is a sign error. So I have opposite of b, opposite of -5, so it's opposite of negative is positive, so that 5 was right. Now, remember, -5 times -5 was 25, so that is right. And I got -4 times -3, which is plus 12 times 1. So I got adding 12 underneath, and I got over -6. So now I'm looking at this, and my answer is going to be 5 plus or minus the square root of 37 over 6, -6. Now, this plus or minus is kind of an issue. Okay, let's talk about the plus version. So I've got 5 plus the square root of 37 all over -6, or I have 5 minus. Now let's talk about the minus version. The minus version is minus the square root of 37 all over -6. Notice the things that just changed. Now, when I plop this in my calculator, so I grab my calculator, and I want to make sure you put this in because this is important when we're doing this. I have left parenthesis, this is my numerator, the top value, 5 plus the square root of -7, 37. Okay, now arrow out, and now I'm going to divide this by -6. This is going to give me this answer, -1.81, -1.847. Now, the other one, remember, I have replaced that with a negative. So I'm going to hold second, enter, and I'll replace that top value with a negative sign or subtract sign and hit enter. Now, these are my two values. So I have my x value equal -1.847, or I have it x equal 0.1080 if I leave it out the 3 digits. Okay, but these are exact, these are approximates. Okay, so we've used quadratic formula to solve for something, and we've used factoring to solve for something. Let's move on. Now, similar figures have the same shape, but not necessarily the same size. You can abbreviate is similar to with this little sign. It's called a tilde, but we read it as is similar to. Essential understanding, you can use ratios and proportions to decide whether two polygons are similar and to find unknown side lengths of similar figures. First of all, if the sides or the figures are similar, their angles have to be congruent. All the angles are identical, okay? The sides are proportional. The angles are the same. So if two polygons are similar polygons, if corresponding angles are congruent, and if the lengths of the corresponding sides are proportional. So I check out my angles, 90, 90, congruent, congruent, 90, 90. Okay, we got this. BC, HI, CD is to IJ. AD is the GJ, and AB is the GH. Check it out. AB is the GH, BC is the HI, CD is to IJ, and AD is to GJ. Now, they have to be lined up with corresponding sides. I identify the corresponding sides based on the angles that are provided. Okay, now you write a similarity statement with corresponding vertices in order, just as you write a congruent statement. Please notice we have that set up. Angle A is corresponding to angle G, so A and G are congruent. B and H are congruent, C and I are congruent, D and J are congruent. order matters. When 3 or more ratios are equal, you can write an extended proportion. The proportion of AB to GH equaling BC to HI equaling CD to IJ equaling AD to GI is an extended proportion because it's more than just 2 relationships. Now, a scale factor is the ratio of corresponding linear measurements of 2 similar figures. The ratio of the lengths of corresponding sides, side BC and segment YZ, are more simply stated. The ratio of corresponding sides is BC divided by YZ is equal to 20 divided by 8. Now let's talk about BC. BC is 20. YZ is 8. So that's where we get 20 and 8. I reduce, both have 4 on the top and the bottom, and I get 5 over 2. So the scale factor of triangle ABC to triangle XYZ, now notice this order is important because the information of ABC is on top and the XYZ information is on the bottom. XYZ was 8. ABC 20. So BC is from ABC. YZ is from XYZ. So BC 20 on top. XYZ, YZ 8 on the bottom. That's how we can say 5 to 2 or 5 to 2. Now, if I wanted to switch it, I could say, so the scale factor of triangle ABC to XYZ is 5 to 2, but what about the scale factor? What about the scale factor of triangle XYZ to triangle ABC? What would that be? Now, XYZ is on top, so it'd be YZ to BC, which would be 2 to 5. It's reciprocal of the one I just gave, but you have to keep in mind the information of which triangle would be on top. Okay, so be careful. You will have a test question or a quiz question about that, or even assignment questions. We're not even limiting it to assessments. We're just talking about our daily assignments. Sliding on here, understanding similarity. Similarity, remember, this tilde says triangle MNP is similar to triangle SRT. In similarity, order matters. So they're asking, what are the pairs of congruent angles? I don't even have to look at this. We don't even need this picture because we are given a similarity statement. So this statement of similarity, angle M, angle N, angle P, all from this triangle, are congruent to, keep in mind, these are all congruent because for triangles to be similar, any shape to be similar, corresponding sides have to be the same. So M is in the same position as S. Oh, it's angle S. And N is in the same position as R. Oh, N is congruent to angle R. And angle P is in the same position as T, so angle T must also be congruent to angle P. That is order matters. Okay? So we have this statement of similarity. It tells me it's exactly what things are corresponding to each other, and the order matters. Now, they're asking us, what is the extended ratio of the proportions? So what is the extended proportion of the ratio of the corresponding sides? Now, we got to think about corresponding sides. This is tricky. So we know that M and S are congruent, but let's go back to our original statement. I know that triangle MNP is similar to triangle SRT. I know segment MN is related to segment SR. Okay, those are in that order. I know NP. NP is related to which one? ORT. And then MP is related to ST. Well, keep in mind I did the same order each time, and that's my extended ratio for this set of two triangles. Mn is the SR equal NP divided by RT is equal to MP over ST. Now I could have done the reciprocal of those, but I'd have to do the wholesale reciprocal of the entire relationship. Those are the extended proportion of the ratios of corresponding sides of those triangles. So keep that in mind, what that means. Corresponding sides are going to be an important thing for us to keep in mind. Now, determining similarity. Are the polygons similar? If they are, write a similarity statement and give the scale factor. Well, they're talking about JKLM and TUVW. JKLM and TUVW. Well, JK and TU have corresponding angles going across, double to single, double to single, single to double, single to double. So I could say here that I've got JK to TU because of the angle markings, KL to UV because of the angle markings, LM to VW because of the angle markings, and MJ to WT, again because of the angle markings. I went big shape over little according to the picture. Okay, that's what we've got. So let's just double check to make sure I wrote them down right. JK, TU, KL, UV, LW, VW, LM, excuse me. I've got LMVW and MJWT. Let's put in some numbers. So I got JK is 12 to 6, and I got KL is 24 to 16, and I've got LM 24 to 14, and I've got MJ 6 to 6. Now, if these were truly going to be proportional figures, right now I know the angles are the same, but if they're truly going to be proportional, all the relationships that I've just written down should be equal. This is 2. This of 8 is in both. This is 3 halves. Well, this is 12 sevenths. Wow, this is not working out at all, is it? And that's 1. Are any of these equal? And remember, for it to be a proportion, for these to be similar shapes, they have to all be the same. So shapes are not. Let's be more specific. JKLM is not similar to TUVW by definition of similar polygons. And all I did was line up corresponding sides. Now, here's the thing. I did a longer one. I want you to look at the markings here and to line them up the way I just did and to see if these two triangles are similar. Shut me off and see what happens. Go. Shut me off. Listen to the video. Shut it off. Okay, welcome back. I've got a single to a double. Single to a double. I got CA. Single to a double, single to a double, FD. That's one relationship. I've got a double to a triple to a triple, double, AB. Notice I'm staying with one side up top, and I've got the double to a triple, DE. And now I've got my triple to a single, right? I got a triple to a single, my triple to a single, BC, triple to a single, EF. Now let's fill in the values that I have in the problem. So CA is 8. FD is 10. Okay. AB is 12. DE is 15. BC is 16. EF is 20. Now, these should reduce to be the same value. Let's see what happens. I take 2 out of top and bottoms. I get 4/5. I take 3 out of top and bottom, I get 4/5. I take 4 out of the top, I get 4/5. All are equal. So triangle ABC is similar to, check it out, to triangle EFD, definition of similar polygons. Woohoo! That's our final step there. All the angles are congruent and the sides are proportional. Now, that's what we got for today. Okay, hopefully things are going well. If you don't understand what's going on, do not sit there. Do not just sit and I'll eventually get it. Make sure you contact your local geometry teacher and ask them a question. I hope things are going well. And remember, I'm Mr. Bloom and you're not. Have a great day.